I want to use this 10-minute video to explain everything you need to know about separation techniques. Let's dive into it. Now, separation techniques is a chemistry process where we want to separate mixtures. Underline the word mixtures. Now, of course, you know that mixtures are physically combined substances, like substances will combine physically. That is, you can see them. They are not chemically joined together, unlike compound. Compound are what? Chemically combined. Why mixtures are what? Physically combined. Physically combined. Okay. So take note of that. So that's where we can use what we call what? Separation techniques. Now let's delve into it. The first one we're talking about is what? Is sieving. I will not be wasting much of your time. So please follow me. Now, sieving, I'm very sure you are familiar with this. What Jamb will ask you is what is the property used in sieving techniques? That's what Jamb will ask you. And what will you tell them? We say we use what we call the principle of what? Different sizes. I've seen a question where they said the same sizes. Please don't go and make the mistake. Is what? Different sizes. That's what we use. And you will all agree with me that if you have your, let's say, a mixture of your beans and your rice, like maybe you have perhaps you just make a mistake where you pour beans and rice together. What will your mommy ask you to go and bring that sieve? What the Yoruba call ase. Go and bring that sieve, such that if you sieve it, because the size of rice is different from the right size of beans. The rice, because it's smaller, it will go down, right? It will start sieving. It will start sieving, right? It will start sieving such that the beans will be on top, will be inside the sieve, while the rice will be down. So what do you see? What the property do you think we use? Is that because the rice and beans, they are of what? Different sizes. That's all you need to know. This is what Jamb will ask you. The properties we use here. Properties. Now, what's number two? Because I don't want to waste your time. Exam is fast approaching. Number two that I'll be talking about is what? Decantation. Please listen. There's something I have to say here. Decant. This one, I can explain it while sleeping because you are doing it at home. When you drink Gary, you realize that when you drink Gary, aside from the Gary itself, you realize that there will be some small particles on top. What do? You want to decant. You want to decant it, abi, into another bowl. You want to decant it. So the process of removing these small particles on top of a Gary is called what? Decantation. You are decanting the Gary particles inside it. Now, Jamb will ask you a question. Which separation techniques is impure or is the most inaccurate form of separation techniques? Is decantation. I will tell you why. In the process of decanting that particles, don't you think that some Gary will follow? Exactly. So it's not an accurate separation technique because eventually you waste a little of your Gary. Okay, so that is why this decantation is an inaccurate separation technique. It's a Jamb question, but this is the process. Now, number three. Number three is what? Is filtration. Filtration. Now, here we deploy what we call a filter paper. In what we call what? A filter paper. I don't know if you are in your secondary school, you would have done this experiment where you fold that paper, right? Now you put a salt, you understand, here that can pass through this filter paper. Now eventually two things will happen. The filtrate will be here. The filtrate, while the remaining on this that cannot pass through this filter paper will be called what we call what? A residue. A residue. So that's the process here. So we deploy what we call using a filter paper, where the filtrate will pass through the filter paper. The residue will be on top here. So that's the third one. I don't want to waste your time. I said 10 minutes. Now, the number 4. Hope you get all this. Please take note of this. This one is very important. Please take this inaccurate decantation because Gary will follow. Very, very important. Now, the fourth one is what we call evaporation. Evaporation. Now, this one must be for Now, if you want to use evaporation, it must be non-decomposable salt. The salt must be what? Non-decomposable. That is, it cannot decompose. You understand? Non-decomposable salt. Now, what do we mean? Because if you have, let's say for instance, your NaCl and you heat it up, if this salt is going to be decomposable, eventually you will not get your product, what you eventually want to filter, what you eventually want to separate, what you eventually want to get the proper part. So for instance, NaCl is not decomposable. So, or a very fantastic one that is not decomposable, because this one you need it. Na2CO3 is not decomposable. K2CO3 is not decomposable. Please take note of this. So if you, for instance, the reason why I'm using NaCl salt is because your normal salt at home. Now, let's say for instance, maybe in the kitchen you pour water inside NaCl. You know what your mommy would tell you to go and do? Go and expose this salt under the sun, because evaporation, right? So it deals with the surface where the water is. So the water will just, will leave while still retaining the salt. So this is the water leaving while the salt will still maintain. So if you want to go and dry that salt that you mistakenly pour water on, what do? You evaporate. You understand? But what is important is that the salt must be non-decomposable, because if it is decomposable, if you eat it, if you pass it, eventually you will not get your salt, which is not the purpose of separation techniques. So please, non-decomposable salt. It's because I don't want to waste your time. Hope you get this. Evaporation. Now, that's number 4. Number 5. Number 5. Number 5. Okay, I have to clean it because I have to explain that one very well. Is chromatography. 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 Photography. Now, what is the principle? What is the property that is being used here? Is what they call speed. Speed, or some people call it velocity. Now, we have a chromatograph. You have a chromatograph where you can have a solute. Now, another very important thing is that of a pure substance is that they form a single spot. Pure mixture, see, please take note of this one. Pure mixture forms a single spot on a chromatograph paper. Single spot. If it's not pure, it will form multiple spots. So if it is pure, it forms a single spot on a chromatograph paper. Now, let's say we have the solvent. So you're expected to move, right? You're expected to move. The solvent is expected to move, while the solute is also expected to what? To move. You understand? The solute is expected to move. The solvent is also expected to move. So there's something called coefficient of how they move. This spot that is being here, these are solutes here, and they are all inside a solvent. So they are expected to move. You understand? So there's something called the end of the solute to the end of the solvent. Okay, now this one is not important. I just want to let you know how this whole thing happen. Okay, so that there is called coefficient. Okay, how this particular solute moves in respect to the solvent, okay, is called coefficient. So the idea is that there is a speed in which this is being checked in. So the difference in speed, or sometimes they call it velocity, is the property that is being used in a principle of chromatography. Okay, the difference in the speed. So this is a spot, okay, on the chromatograph paper. You understand? This is the solvent, and this is the what? The solute. So it's the solute that is forming spots on this chromatograph paper. Okay, I hope you understand that. So what is the property being used? The speed, you understand, or so that they call it the rate of migration. Another textbook, you might see what we call rate of migration. In case you don't see speed or velocity, you can see rate of what? Migration, because they are migrating. That's another thing you have to take note. Okay, rate of migration. That's number 5. Now let's move. Another properties or another principle of separation techniques is distillation. Now distillation can be two. It can be simple distillation. It can also be what? Fractional distillation. Okay. Now for what is being used when we talk about distillation is what we call what? Boiling point. Difference in boiling point. That's the property we use. Difference in boiling point. That's the property we use. Difference in boiling point. Now, if it is simple distillation, there must be a wide range. Okay, there must be a wide range of that boiling point. If it is fractional, it must be a close range. I'll give you an example. It must be a close range of boiling point. Now, for instance, water, the boiling point of water is 100 degrees Celsius, while the boiling point of ethanol is 78 degrees Celsius. Now, don't forget that this guy, there must be miscible. There must be what? Miscible. Very, very important, because if it is immiscible liquids, there's another one we use. So there must be miscible. Okay, that is, they must be able to mix together. That's what it means by miscible. So if you want to separate water and water, a mixture of water and ethanol, because the boiling point is different, right? That means we will get to 78 before we get to 100. So by the time we get to 78, ethanol will just boil out. Then when we get to 100, then water will follow. So difference in boiling point. So what type of fractional, what type of distillation are we going to use here? We are going to use what we call simple distillation, because the difference between 100 and 78 is wide. So we use simple distillation here. Now, for fractional distillation, you should know this because it's a very important topic in chemistry. You should know it because it's a what? Very important topic in chemistry. And that is what? Fractional distillation of crude oil. Fractional distillation of crude oil. So petroleum is not the same thing as petrol. Petroleum, petrol is a product, or is one of the products of petroleum. Petroleum is the same thing as crude oil. So when I tell you that you are crude, it means you are unrefined. You are unrefined. So when this guy undergo what we call fractional distillation, that's when you'll be seeing that it will be giving out different products. Okay, some of them is what? Petrol. Another of them is what? Kerosene. Right? Another form of the product is what? You see diesel. But there's one that is very, very important. Now, another thing that is important here is that this is starting from, they are carbons, but this one is C12. Okay, kerosene, because it's a Jamb question. It's starting from C12. Okay, so there is diesel, there is bitumen. Okay, Abi, and sometimes they call the last one is bitumen and asphalt. Okay, bitumen and asphalt. So please take note of this. Petrol, kerosene, these are products that will eventually be out when you do fractional distillation of petroleum or fractional distillation of crude oil. Okay, so petrol is a product here. Petrol is from C4. Okay, now I just want to, I'm not dealing so much with this. Okay, don't forget that the last product of fractional distillation of petroleum is used in construction of pitch. Okay, you would have seen it when they want to construct road. Also road, you understand? You see where they use all this last product of petroleum to construct road. You understand? That black, very black um product that you see that for construction of road. Okay, that's what you have to. So what is the property use? Boiling point. So if it is simple, it is wide. If it is fractional, it is close range. Okay, so and also we should, maybe I'll talk about it. You should also note the temperatures and everything where these ones will be coming out during fractional distillation. I want to talk about fractionalization. I just want to explain this so that this is not long, so that you can be able to get it very fast. Okay, this explain this. So next one is what we call okay, which one have I not mentioned? Okay, separating funnels is not SEPEO, it's SEPA, separating. Okay, like separating, but it's A. Now this one we use it for immiscible liquids. Immiscible liquids. Please take note of this, very important. So the principle of immiscibility is what we consider here. Immiscible liquids means liquid that cannot mix. What are they? Kerosene and water. They cannot mix. So how do you separate them? You separate them using what we call separating funnel. So kerosene and water, you cannot mix them. Petrol and water, can you mix them? No. Petrol and water, cannot mix them. So non-polar and polar. So you cannot mix them. So something like this, you use separating funnel. So what is the principle that we use? Principle of what? Immiscibility. Okay? Immiscibility. That's what we use in this case. Please take note of that. Very, very important. So which have I not mentioned? Okay, crystallization. Yes, very important. Crystallization. Just like separating, just like distillation, crystallization is also two. We can have simple and we can have what? Fractional. Now, don't forget, we talk about non-decomposable salt. Now, we use crystallization for decomposable salt to separate decomposable salt. What are they? For instance, CaCO3 is decomposable. NaNO3 is a decomposable salt. So this kind of salt, you cannot use evaporation to separate this. You want to use crystallization. Okay, and it is also based on if it is close or if it is wide. So if it is wide, we use what? Simple crystallization. If their boiling point is also low or close, we use fractional. So what am I trying to talk about is that there must be decomposable salt for you to use crystallization. Okay, it must be a decomposable salt. Please take note of that. Very, very important. It must be decomposable salt for you to use crystallization. Unlike because you cannot evaporate this guy. The moment you evaporate them, they will decompose. They can decompose. So you are not eventually getting the salt. Because the idea of separation is that you want to get this salt out. And you want to get this salt out. So if you are evaporating this, you cannot get the salt. Okay. I think the last one is magnetization. Of course, any substance that has a magnetic property, for instance, such as iron. If iron is mixed with other substance, so you want to use magnet to attract iron. You understand? So that the other substance is also left behind. So that is a very good example of magnetization or as a means of separation techniques. So I want to give you a question. But before that, if you have not joined our class, send us a DM on WhatsApp. You'll see around the description or anywhere to join our Jamb class that started. But before that, I want to give you a question. So I want to ask you, how do you separate a mixture of, question one, a mixture of, let's say, gari plus rice? How do you separate that? Number two, how do you separate water plus oil? So answer this question, and in the comment section, how do you separate a mixture of gari plus rice and water plus oil? Okay, answer that in the comment section. So I hope you understand all this. That's why I listed them here, so that we will not miss out anything. Okay, so we talk about filtration, we talk about this, 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 talk about this. So I eventually use how many minutes? Oh, 20 minutes. But then I hope you got value. I hope it's worth it. So with this 20 minutes, you are done with separation techniques. Just go and do the exam. So bye. Answer the question in the comment section and see you in the next video. Bye.